Hello! Here we go with Chapter 10. We get into the heart of second semester. Okay, we will use Chapter 9 just a little bit. You'll see it on the AP test just a little bit. This stuff, we will. For those people who like a title, this is called Confidence Intervals. Confidence Intervals. So here we go. Here's our problem. Okay, very typical type of problem you will see in Chapter 10. It says, you own an apartment. You buy it, you're going to rent it out. You want to know how much to charge for rent, so you look around the city to see. The mean monthly rent for a random sample of 50 apartments. Again, a random sample is fantastic. Hopefully you don't look at just 50 apartments in one location. Hopefully it's random. You give all the apartments a number, which is not that hard to do, and you randomly get 50 different apartments, and you find that the average of those 50 is $540 a month. You figure out, using your calculator, that the standard deviation of the sample is $80, and we are going to construct and interpret a 95% confidence interval for the mean monthly rent for an apartment in the city. This semester, lots of problems, not all, but lots of problems, are going to look something like this, and they're going to follow a four-step process. 4 steps, answer, and give everything we need. Now, technically, you can do them in any order, and technically, you don't have to label them step 1, step 2, step 3, step 4, but I think it helps a lot, and I've graded a lot of AP tests. The students that know their steps, know step 1 and step 2, they do pretty well. So, here we go. I will try to explain at the end what a confidence interval is, but I'm going to go through the 4 steps here. And the great thing is, this week I'm going to show you the confidence intervals. Next week, when you come back, hopefully, we'll spend a whole day reviewing all of them. Okay, there's 2 main ones, and then kind of a short third one. So here we go. Step 1 is you need to give it the proper name. The proper name. So the question you need to ask yourself is, am I looking at an average? Am I looking at a mean? Or am I looking at a percentage? Or am I looking at a proportion? Is it a mean problem or a proportion problem? Normally the last sentence will clue you in. Construct and interpret a 95% confidence interval for the mean. Okay, so it's a mean problem. And it's a 1 sample. We took 1 sample of 50. This whole chapter is 1 sample. Later on, in a month or so, we'll do a 2 sample, but it's 1 sample. And I'm going to throw a letter in there, and I'll talk more about it at another time, but it is a 1 sample T interval. Mr. Mack, what in the world is the T for? I'll talk about that later. It's not important at this time, but is the T interval. The very short answer is, since we're using a sample, it's not normally distributed. It's because it's a sample, so we're using an estimation, so we use the letter T. But it's a 1 sample T interval for the mean. Okay? 1 sample T interval for the mean. You'll get used to it after a while. I know on day 1 it looks a little weird. That's step 1. All you need to do is give it a name. 1 sample T interval. That's what we're working on today. Step 2. We call it the conditions. Am I allowed to do the math? This is essential in real life. number one, where do we get this data from? Is it random? Is there any randomness in this problem? Yes, it comes from a random sample. That's huge in real life. Okay, if I don't have a random sample, I just look at one apartment complex, that's not good. But I did get a random sample, so I need to state it. So I'm going to say a simple random sample is stated in the problem. Okay? Very huge. It's not hard to look at the problem to see if it's random, but it is important. So random sample is stated. A simple random sample is stated. Next is it normal? Is there a possibility that this comes from a normal population? Okay? So hopefully from last chapter, there's a number up there that's like, of course this is a random sample. Okay? How big was our sample? Random sample of 50. So hopefully from last chapter, you're thinking 50 is greater than 30, so I can use the central limit theorem. And that's correct. So this is from last chapter. It is approximately normal. And then you got to give a reason why it's approximately normal. Because 50, our sample size, is greater than 30. And then you have to say by the central limit theorem. On a test, you cannot write CLT. AP Stats does not want you to do it, so I'll count it wrong. But for notes, I'm going to put it on there. We need these three things, which hopefully look a little familiar from last chapter. It is approximately normal, because 50 is greater than 30, according to the central limit theorem. Step 1, give it a name. Step 2, conditions. Step 3, oops, I want a blank page here. Step 3 is use our calculator and get some numbers. So pause it if you don't have your calculator. Go get it. Here we go. Calculator time. Turn on your calculator. And we want to go to, let's see, tests. Where is that? Oh, stat, I'm sorry. Go to stat, there we go. Then you're going to go over to tests. And we're going to use a bunch of these. But there's only one we're learning today, and it is a one sample t interval. And that is number 8, a t interval, number 8. Hit enter. And you want to go over to where it says stats. And we're going to enter the correct numbers in here. The X bar is the sample mean. So you go back to your original problem. Oops. Go back to the original problem. What was the sample mean? Took a sample of 540 is our sample mean. 540. So we put 540. And then S of X is the sample standard deviation, which I believe if you go back is 80. N is the sample size. How many apartments did we look at? I believe that was 50. And then the confidence level, which I'll go more in depth with, of why it changes. Well, we just look back at the problem, and I think the problem said 95%, which is a very traditional one, 95%. So this is what you should have. Step 3 is, can I use my calculator correctly? Hit calculate. And we write these numbers down. 517.26. 517.26. 517.26. What was the other one? 562.74. 562.74. 5. 562.74. And that is step 3. Can I use our calculator correctly? Now I'm going to go into explanation what these numbers actually mean here in a second. But step 4 is writing a sentence, interpreting it. Step 4. We are 95% confident that the true mean amount per month for an apartment is between 517.26 and $562.74. And that is our sentence. Some key points in the sentence are we're talking about the mean, and we're trying to figure out the actual population mean of all the city's apartments. So the true mean. You may write the word population mean if you want. I write the word true because it's shorter. But you can write the population mean. And then I put it in context. What is it of? It's a mean of apartments. And then I have, of course, numbers, but I have the units. So those are the key points. If 4 is a little tricky for you, go back to the original problem and you look and you say, we are 95% confident about the true mean. You can just almost copy this. For the true mean monthly rent for apartments in the city is between this amount and this amount. Okay? That is the 4 steps. I'm going to try to explain this quickly in the next minute or two. But what are we doing? Okay? We want to figure out the entire population apartment monthly average. Okay? In a city maybe like Elkhart, I don't know how many apartments there are. There's a lot. There might be thousands. I'm not going to go to every 1,000, every apartment. So I take a sample, okay? And I take a random one, which is good. And I figure out, hey, the sample average is 540. Do you think that the entire city's average is $540? Probably not. It's not probably exactly 540, but it's probably pretty close. Okay? So what your calculator is doing is, and we would have more time, but this year is different. Your calculator is doing is saying, hey, we have a really good guess. The sample average. But we're not sure of what it's going to be. So we're going to add and subtract what we call a margin of error. Okay? So it's going to add or subtract a margin of error. It's going to give it some room to say, we know it's not exactly 540. We think it's close. So we're going to calculate this margin of error. And it's not essential that you know what that margin of error is. Okay? But margin of error takes into consideration this 95%. Okay? And I'll talk more about that hopefully when we get back. But that is what your calculator is doing. The middle of a confidence interval is the sample average, and then it gives us this margin of error, which has a couple of components. One of them based upon this, what level of confidence do you want? Now stay with me. I know it's a long video, but today you don't have to do any work. What do we got? Got a couple of things. Talking about margin of error, I did that. What's the difference if I choose a 90% rather than a 95%? I will tell you, and we'll talk more about it, is which one is wider? 95%. The bigger the level of confidence, the wider it's going to be. Okay? The bigger the confidence level, the wider it's going to be. Okay? And the very last thing that we're going to do for this video, I know we have a lot of notes today, but you don't have to do any work, so that's kind of nice, is what does a confidence interval mean? This is what a confidence interval means, what a confidence level means. It means if we do the same process over and over and over and over and over and over again, okay, we keep making these confidence intervals. We keep, oops, went the wrong way, haha. We keep making these confidence intervals. We take a sample of 50 and we make a confidence interval on our calculator that 95% of those confidence intervals will capture the true mean. Okay, I'll go back to it. 95% of those confidence intervals will capture the true mean. I'll keep going over that a lot. I gave you a lot of stuff. I'll go through a joke here, and we'll see how you're doing next week. If we have to postpone the test, we can do it. But next week, we will have a whole day to review. And, all right, here's a joke. What happens if you drop your iPhone and your iPad in the water? They sink. Ha ha! Have a good one.